This is year 9 notes, and we're on our final unit. This is unit 9, and we're looking at some transformations. So the first one is reflection. If you reflect an object in a mirror line, the image will be the same shape and size. To find the image after a reflection in the line, count the perpendicular distance from each corner to the line. Count the same distance on the other side. Now, most of you can just see this and you can see what shape it's going to be, but that advice above is really good. Whenever you get further up the school, the reflection lines don't look like this, they're maybe like this, and it's really quite hard to see how it reflects across. So count the perpendicular distance from each corner to the line. So this one's touching the line, so this point's just going to go here. This one, the perpendicular, so perpendicular means at right angles too. Let's move this up so we can see it slightly better. So here's the line, and at right angles in, so it's these lines here, so that's 1 square away, so we want to go 1 square down here. The next one here is 1, 2, 3 squares away, so we go 1, 2, 3. This one's 3, 1, 2, 3, so we go 1, 2, 3. And then again this one's touching, so we can just put it right here. With our ruler then, we want to join up our dots. Like this. And this then is a reflection of this shape given that mirror line. Okay. Next one, draw the image of shape A after a reflection in the line x equals 2. Now by far the hardest bit of this is this bit here. It's the line x equals 2. So the line x equals 2 is a line on the coordinate plane. You can see there's a change here from just squares to actually going to kind of x and y axis here. Y axis, x axis. But the line x equals 2 is the line where all the x coordinates are 2. So let's pick a few and see how I go. The point 2, 3, for example, the x coordinate there is 2. 2, 3 would be here. Well, another one, 2, 1. 2 across, 1 up. And you start to see the line 2, 0. There's 2, 0, so we can see then the line x equals 2 is going to be this line here. And so we end up there with that. Reflecting these across, so this one's, now remember we're counting the squares this way now. This one's touching, so this is here. This is 2 squares away, so we go 2 squares away here. This is 2 squares away, go to here. This one's touching. This is 1 square away, and this is 1 square away, so we can join then up our points. Do it nice and heavily, it should come out. Do my double line so we can see okay. Another wee thing just to say about the line x equals 2, just while I'm drawing here, would be that people confuse this because they think the y-axis, you know, is a vertical line, which it is. So you think the line y equals 2 is going this way, but it actually goes the other way than you'd think. And so we have it that way, but that's our line then, x equals 2, and that's the shape A reflected across. Let's look at the next page. We should also be able to describe a reflection. So when describing a reflection, you must give the name of the transformation, that's a reflection, the equation of the line in which the reflection takes place, for example, a reflection in the line x equals 3. Describe the transformation fully that maps A to A dash. So this is A, and this is A dash. And so a reflection line, let me see how many squares. So there's 1, 2, 3, 4, 5, 6, 7, 8. So the reflection line must be halfway along, so it's right on the y-axis. So that would be my reflection line there. So let's describe then this transformation, and that'll be us done. So this transformation, just try to judge this so you can see it. A reflection in the line x equals 0, and that's the name of this line here. All the x coordinates are 0, 0, 1, 0, 2, 0, minus 1, 0, minus 2, and so on. If you wanted to call it, you could write y-axis also, which would just be the same thing.